You had a nice mix of homework last night. We got a little bit of combinations and permutations, a little bit of the trig stuff that we talked about, and then some quadratic stuff to review. I'm going to start with the combinations and permutations. You had to do 15 through 18. This is all just punching stuff into your calculator. So for 15, you're just going to figure out what 10p4 is in your calculator, and then divide that by 4 factorial in your calculator, and you should get 210. Alright, there isn't really any work to show for that one. For 16, remember that when you have numbers written in this weird parenthesis, this is the exact same thing as if I said 15, choose 5. Alright, so this is the other notation for combinations. We don't have another one for permutation, so you're just going to do this in your calculator, and you should get 3003. It's going to be the same thing for 17. When you have 15 up here and 10 down here in parentheses like this is the same thing as 15 choose 10, which you're going to do in your calculator. And you should get the same thing, 3003. Okay, remember, to get to combinations and permutations, you hit the math button on your calculator, you go all the way over to the right, and then you can pick. The reason that these things are equal, which is kind of cool, they're the same because I'm picking out of 15 and 5 and 10 add to 15. Alright, so that's kind of cool. So if I would have done 15 choose 2, that would have been the same thing as if I did 15 choose 13. Because 2 plus 13 adds to 15. Alright, fun fact for you. And then for 18, that's just going to be 4 choose 4, which, again, you do in your calculator. 4 choose 4, and you get 1. Alright, easy. Moving on to the next page, this is the trig stuff that we were talking about in class, okay? And here they're just giving you an equation, and you need to identify the amplitude, the period, or the phase shift. Alright, remember the amplitude was the number that we multiplied on the outside. So for number 3, this is really a 1 sine x, so the amplitude is just 1. For number 4, you have a 2 multiplied on the outside, so the amplitude is 2. For number 5, you have a 5 multiplied on the outside, so the amplitude is 5. And for 6, you have a 3 multiplied on the outside, so your amplitude is 3. Alright, no work to show for that, just can you tell that the amplitude is what you multiply out on the front. Okay? For period, remember, period, and I'll write this down, period, is 2 pi divided by the frequency. Q-U-E-N-C-Y, there we go. Alright, remember, because 2 pi is how big the unit circle is, so how long it usually takes to complete one cycle of sine or cosine, and then we divide by the frequency, which is how frequently this wave is going to happen between 0 and 2 pi, and that's when we multiply it on the middle. So if you look for number 1, I have a 1 on the inside. This is a 1 sine x, so for 11, my period is going to be 2 pi divided by my frequency, which is 1, which is just 2 pi. So from 0 to 2 pi, I will go through 1 sine curve. For number 12, this is also, 1 on the outside, that would be amplitude. I have a 1 right here on the inside, a 1x. So my period, this is going to be the same thing. It's going to be 2 pi divided by the frequency, which is 1, which is just 2 pi. So by the time I go from 0 to 2 pi, I will have gone through 1 cycle of my cosine curve. For 13, I have a 3 being multiplied on the inside. So this curve has a frequency of 3. So that means that by the time I go from 0 to 2 pi, I will have had to draw 3 full cosine curves. Okay? So to figure out the period, to figure out how long it takes to get 1 cosine curve, I'm going to do 2 pi divided by the frequency, which is 3, and that's your answer. Okay, so by the time I go from 0 to 2 pi over 3, I should have gone through one full cosine curve. And then for 14, on the inside I'm multiplying by 2. So for 14, my period is going to be 2 pi divided by the frequency, which is 2, which is just pi. So that means that by the time I go from 0 to pi, I need to have completed one full sine curve. Because this frequency of 2, is telling me that by the time I go from 0 to 2 pi, I should have had 2 sine curves. So your frequency tells you how many curves by the time you get to 2 pi, and the period tells you how long to complete one. Okay? And 19, 20, 21, 22, we didn't talk a whole lot about phase shift, but just remember that phase shift is when you add or subtract something on the inside. So that's if this moves to the right or to the left. So for 19, I have a plus pi over 2 in here. The plus means I'm moving to the left. All right, I know you want to say you're moving to the right, but you're moving to the left pi over 2 units. So this is taking your normal cosine curve and you're moving it to the left by pi over 2. So for 20, you have a minus pi over 2. The minus means you're moving to the right pi over 2 units. For 21, you have a plus pi over 3. So this means the plus says you're moving to the left pi over 3 units. And remember, pi over 3 in radians, that's 180 over 3, that's 60 degrees. All right. And then for 22, you have a minus pi over 4. The minus means you're moving to the right. And the pi over 4 is how far you're going. And remember, pi over 4, that's 180 over 4, which is 45. Easy, no calculations really, except maybe dividing 2 pi by something. And then this is kind of just a review. This is solving quadratics using the quadratic formula, but they tell you that you're going to get imaginary roots. So here I know that since I'm going to have imaginaries, I am going to have a negative under the square root symbol. So for number 3, and I'll come over here. Remember the quadratic formula. You need to memorize this. It's not on your reference sheet. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. So for number 3, x is going to be equal to negative b, so that's positive 4, plus or minus the square root of b squared. Notice I put the negative and the 4 in parentheses. B squared minus 4ac all over 2a, and a is 1. So that's going to be 4 plus or minus negative 4 squared is 16 minus 32 all over 2. So you're going to get 4 plus or minus the square root of negative 16 over 2. Now, we know that this is not real, okay, because you have a negative under the square root. But now that we have imaginary numbers, we know how to deal with that. Okay, remember, and I'll put this over here, we can rewrite negative 16, the square root of negative 16, as the square root of negative 1 times the square root of positive 16. And the square root of negative 1 is I. So this is just I times the square root of 16. So I'll write that over here. So this is going to be 4 plus or minus I square root of 16 all over 2. But we know the square root of positive 16, that's 4. So this is 4 plus or minus 4i over 2. And 2, now you got to be careful, 2 cancels into both of these. It has to cancel into both. So you're going to be left with 2 plus or minus 2i. Done. So same old quadratic formula, but now that we know imaginary numbers, when you get a negative under there, there's more work to do. and now I will do number 4. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's going to be negative 6 plus or minus the square root of 36 minus 40 all over 2, which is negative 6 plus or minus the square root of negative 4 over 2. But we can write that as negative 6 plus or minus I times the square root of 4 over 2. Alright, just like I did up here with this negative 16, I can rewrite the square root of negative 4 as this. And then that becomes I times the square root of 4. I just kind of jumped down there. But we know the square root of 4, that's 2, so this becomes 2I. And then 2 cancels into both of these, so you are going to be left with negative 3 plus or minus I. And that is it.